Welcome to 501 Mat Lead, where we work smart, not hard. In today's video, we'll be determining the area of the Sierpinski carpet. What is the Sierpinski carpet? Well, it is a fractal that is achieved by an infinitely iterative algorithm. We start off with a square of unit area. We then subdivide it into 9 squares and we take out the middle square. Then each of those remaining squares are further divided into 9 smaller pieces and the middle one is taken out, and that process is repeated infinitely. Pause the video here, see if you can determine the area of the Sierpinski carpet. I'm gonna solve it this way. So as we said, we have that middle square that is taken out. That green one, its area relative to the original unit area will be 1/3 times 1/3, because its length is 1/3 and its width is 1/3 of the original square. So we subtract 1/9. Then the next stage down, that yellow square, that is 1/3 of 1/3, which is 1/9 of the original square. So 1/9 of 1/9 is 1/81. And there are 1, 2, 3, 4, 5, 6, 7, 8 of those. So we then subtract 8 of those 1/81s. Then going down one further level, this tiny little red square, that is 1/3 of 1/3, or in other words 1/9 of the previous one. So that's 1/9 of 1/81. That's going to be 1/729. How many of those are there? Well, count them along with me. We have 1, 2, 3, all the way up to 64 of them. So we further subtract 64 of those 1/729s. Simplifying a little bit, we can multiply and have 8/81, 64/729, and so on and so forth, which we can simplify even more by factoring out that negative sign. And then we can break up those fractions. We can say 8/81 is actually 1/9 times 8/9, and the 64/729 is actually 1/9 times 64/81. And we should be able to see a pattern here, that in fact that 64/81 is actually the square of 8/9. Now we see a very clear pattern and structure emerging here. In fact, this is indeed what we call a geometric sum, where we can compare that to a plus ar plus ar squared, which is the general shape or structure of a geometric sum, which we can find using the formula S is equals to a over 1 minus r, where a is our first term 1/9 in this case, and r is our common ratio, which in this case we identify to be 8/9. Substituting into our formula, we're going to have 1/9 divided by 1 minus 8/9. But 1 minus 8/9 is also 1/9. 1/9 divided by 1/9 is 1. So the area of the Sierpinski carpet is 1 minus 1, which is a big fat 0. Did you get it right? If so, comment below. And as always, if you like this video or found it useful, please feel free to hit that like button, share with others, and subscribe if you're new here.